Welcome to Metallography. This lesson will help you to know how to prepare specimens for metallographic examination. Step by step, we are going to understand objectives, introductions, metallography, and questions. The objective of this lesson is preparing the specimen's surface to be examined for the microstructure study by the microscope, and to learn and to gain experience in the creation of metallographic specimens. Now we are going to study about grain. The microstructure of many metallic or ceramic materials consists of many grains. A grain is portions of the materials within which the arrangement of the atoms is nearly identical, but the oriental or crystal structure of atoms are different. A grain boundary is the surface that separates the individual grains is a narrow zone in which the atoms are properly spaced. One method of controlling the properties of a material is by controlling the grain size. To finish a metallographic process, there are 5 steps. First is cutting. Second is grinding. Third step is polishing. Fourth step is etching. And the last step is microscopy. After cutting, you should start grinding with the paper 180. After 5 minutes of grinding this paper, you will change to the next paper with 240. After 5 minutes, you will change to 320, and after more 5 minutes will be 400. After grinding is polishing. Polishing is the process of creating a smooth and shiny surface by rubbing it or using a chemical reaction, leaving a surface with a significant reflection. Chrome oxide, which we use to polish sample. After polishing is etching. The surface is then exposed to chemical attack or etching with Grand boundaries being attacked more aggressively than the remainder of grand to reveal the microstructure. Light from an optical microscope is reflected or scattered from the sample surface depending how the surface is etched. Here's some suitable agent for some sample materials. These materials will have these suitable agents with specific composition and specific times. Here is the microstructure of aluminum. There are two types of grains, the white grain and the black grain, and each grain is separated by boundaries.
Cut the metal into dimension of 10 by 10. Set the annealing temperature to 723 C and hold it for 60 minutes. Place the specimen into the muffle furnace for annealing treatment. Remove the specimen from the furnace after furnace cooled for up to 24 hours. Mixture cup. Mounting cap. Epoxy resin. Hardener. Pour 10 ml epoxy resin into mixture cup. Drip 5 drops of hardener to the resin. The volume to weight ratio of resin to hardener is 1:5. Stir the mixture uniformly to avoid bubbles. Place the annealed specimen into the mounting cap. Pour the mixture to fully cover the specimen. Leave the mounted specimen for curing in ambient temperature. Remove the specimen from the mounting cap. Grind the specimen on silicon carbide disc. Covered rotating wheel. Spray distilled water as a coolant to prevent overheating. The size range of silicon carbide disc is 600 to 1400 grit. Apply the polishing lubricant on the surface of the specimen. Polish the specimen uniformly on rotating polishing cloth. Etch the polished specimen with the chemical etchant. Nitro etchant of 100 ml ethanol and 10 ml nitric acid is used for etching. Observe the microstructure of annealed specimen under advanced microscopy. Identify the phases of this microstructure.